Hey everybody, I'm Mathias. I go by Mathia on Twitter and GitHub. So Max said that he was told this morning that he had to do a talk. I was literally told 20 minutes ago that I had to do a talk.
Me too, actually.
Right. So this is going to be highly improvised. So I'm going to try to stick with the idea that Michael talked about of having like a flow. So I also work on the DAT project with Max, where we do like fun stuff with replication, right? So one of the examples, I'm just gonna live type some of my slides because I have nothing, basically. So like one of the slides that Max showed was something like this, right? Like Docker run thing. So like I'm very interested in like this step right here, right? The Docker run thing. So has anybody here actually tried to using Docker? Because like I run into this all the time where people have heard about Docker but haven't tried it. All right, has anybody tried pulling an image from the registry? Right. That's a pain in the ass, right? I mean, can we all agree on that? I mean, I don't know what they do with that registry, but I think it's located in California because I'm from Copenhagen, and the cross-Atlantic latency thing, like literally every time I try to do something with it, it takes 2 seconds because it has to do an HTTP connection for every layer, and it's like you end up wanting to kill someone, which is kind of annoying because like killing people is illegal. So I mean, anyways, so I wrote this thing called torrent stream, which is like it's a node module, kind of touching like if we reference back to the node way talk, it's like a small node module that does one thing that's really cool. It allows you to stream a torrent. So it basically allows you to, I think there's an example down here somewhere, right? So it basically allows you to like pass in a torrent or a magnet link, which is just a shorthand for a torrent. And then it allows you to do a read stream to that torrent. So a read stream is basically just saying, I want to get that data for this file in this torrent when you have it, but I cannot try to fetch it on demand, right? So fetch this data in the torrent as quickly as possible, right? So I used this thing to build a video player called PureFlex that just allows you to display video. And somebody used that to build something called Popcorn Time that allows you to show illegal video. But that's unrelated. Back to like, so what does this thing have to do with Docker? Well, it has to do with the fact that I don't want to kill someone when I pull something from the registry. So I made this other thing a couple of weeks back called Torrent Docker, which kind of combines the idea of illegal videos on the internet with not killing someone when you pull a Docker image. So what it does is it's actually really simple, but it sounds really advanced. So like it's something that makes me sound a bit arrogant. But anyway, so it implements a union file system that's backed by Bittorrent for the readable part, but like writes stuff to the local file system. So if you think about it this way, it's like if you can like mount a torrent, right? And then every time you read, and that gives you like a drive, like to a drive, right? And then every time you read something on that drive, this happens. Like, is it local? If it is local, read it local. Is it in the torrent? Then read it from the torrent. So this is basically a union file system because like it has 2 layers. It's a union of these 2 layers. And when you write something to this drive, it basically just says like write to the local file system. Right. All right. Enough talk. So this is fucked up. Whoa. That's weird. So I should probably make this bigger. So I'm just going to demo it because I think that explains it better. So if I boot into, log into a DigitalOcean instance I have running here, I think it's running here. So I'm on Max's TacoNet. It might be, I don't know how fast it is, but all right, it's fine. So like this is a machine that's located in Europe across the Atlantic. All right? In here, I quickly made a folder. It's called One Shot. This machine should have a Docker image Oh, that's annoying. Called test image. Oh. Docker images. Oops. Right. So this has a Docker image called test image. This machine in Europe has a Docker image called test image. I can Docker run this thing. And it boots up a Docker container here that has stuff like Node and shit. Right. That's cool. So what I did beforehand, like 20 minutes ago when Max told me to do this thing, was I exported this thing into a tarball. It was basically just like, you can tell Docker to say, that image there, can you kind of create a tarball that contains the entire file system and dump that out to standard out? So I did that and I saved that in a file. So it's in here. Oh, I shouldn't get that. That was a bad idea. Stop, stop. You get the sense that this thing is big, right? I wanted to do this thing, right? I think you can do the -h. All right, so this is like, literally this is just an Ubuntu image, and the only thing it contains is Node, right? And it's 540 megs. So, I mean, it's kind of big, but it contains the entire Linux distribution. So normally, if I wanted to push this thing to registry and I hadn't pushed any of it before, I would have to push like 550 megs. And even if I push some of it, the way the Docker registry works is I would kind of have to ask for all the layers in my Docker thing if it had that. And again, like going cross-Atlantic, it always takes like a minute for me. I don't know why. So what I did was I ran this command called torrent docker create test image. And what this does is it takes that image, indexes it, like basically just runs through the tarball and figure out, oh, what files are in this tarball, put that in a level DB. I'm kind of assuming people know what a level DB is. gzips that level DB, creates a torrent that contains the tarball and the level DB, and save that here. Here, right. So this thing here, this test image.torrent is a torrent file that references these two files. All right, cool. So what I should be able to do now is I should be able to do torrent docker seed test image.torrent. So now, like my DigitalOcean instance is seeding this torrent. So if I go locally, I should be able to go in here and, oh, I need to, this is the wrong file. I first have to transfer this torrent file to my machine. Oh. Oh. So I just need to copy paste this thing. I'm just downloading the torrent file. So connectivity works, that's cool. So let's get back to seeding this thing. Seed, all right, cool. So locally, I have my torrent file, right? So what I can do now is I can do torrent docker boot, and then I can pass in my torrent file and the name of a container, my one-shot container. That's it. So this gives me like a debug thing here. Oh. So what is actually happening now is hopefully my local computer will connect to the DigitalOcean instance. It's done that now. Like they found each other using the Bittorrent DHT, and it's trying to boot that Docker container. It actually took that torrent and mounted it as a file system on my machine. So hopefully, like we're downloading a bit slow now, like hopefully in a bit it will have downloaded the BitTorrent index and start. Yeah, okay. Wait, that's not good. Let's try again. Boop, 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 boop. So what it's trying to do is it's taking the BitTorrent, it's mounting that as a local file system and trying to boot the Docker container inside the file system by basically fetching any file in that file system based on demand using BitTorrent over Max's torrent, sorry, TacoNet
Oh, yeah.
internet.
Put it on top of the aluminum MacBook.
Right, right, right.
faster.
So, oh, wait. No, this is stupid. Okay, I'm not running boot to Docker locally. I'm just going to boot that up. So I'm on a Mac. I need to run a virtual machine to run virtual machines inside Docker, which is why we love Mac, I guess. It's so easy to use. So let's see, Docker. Okay, so this thing is running now. Let's give it another try. Whoa. Yeah. All right, cool. So now shit is happening down here, right? So like it's mounting the file system, and it's trying to boot bash because that's the entry point of my thing. So basically, this file system is trying to figure out what are all the dependencies of bash. So it's like there's like lib info in there. I don't know what that is. Probably something cool. libdl stuff. And like this is all being, yeah, like this is all being fetched over Bittorrent from like all the peers in the world, which is like just one right now because it's my DigitalOcean instance. Over Max's TacoNet that's running on T-Mobile. So like we're getting there. Apparently, oh, we're getting bash.c. That's probably like one of the last ones. Dear name. Right, cool. So we just booted a 540 megabyte torrent image using BitTorrent over like shitty network, right? And like this thing is totally usable. I can do like ls here, and like it'll have to fetch ls because I haven't synced that, right? And you can even like you can even run Node, and it'll start to fetch that. So you can see down here in the bit. I don't know if you can see it, but like it's trying to fetch Node and all the dependencies, which is like lib standard C++. That's probably cool. And shit, right? And in a second they will have that fetched. So basically the idea is that we just fetch what is needed. We don't need to fetch all these 540 megabytes. And like while we're running this thing, like up in the top corner, this is also seeding the image, right? So if someone else tries to boot my machine, we now have 2 peers. And if that guy tries to run it, we now have 3 peers. And like, you know, it's spreading like crazy, right? Which is really, really cool. So we got Node, and we can run Node now. So that's cool. So like imagine going back to the original example, like I think that was this slide. So we can basically do like that cat. That could be like, fuck it, let's do it live, right? And like you can run into torrent Docker here. So basically you can, using this kind of thing, you could have like a DAT that contained like a terabyte of data piping into a Docker image that's like a gigabyte, but it will all boot in like seconds. So I think that's pretty cool. Anyways, that was the Docker stuff. I'm just, Substack, you're here, right? You're talking about replication, right? Right. So I won't talk too much about it, but like just that. So this is part of our big replication scheme. Like we love BitTorrent, we want to do stuff like that. We're also in the process of discussing how do we actually, like how do you distribute a DAT, right? Git is pretty cool at distributing. Like everybody can have a Git and you can push to each other, and that's kind of cool. So I'm just going to briefly talk about what we're trying to do there, and kind of make the scene for Substack to do his thing. So like we want to be able to do kind of like the same sort of things like Git is doing with, basically Git is multi-master. Like you can have a Git, you can put stuff in my Git, I can put stuff in your Git, and we can sync, and we just resolve conflicts, and it just works. So like basically the idea behind these things is that like everybody has a database. That database has an append-only log. Does anybody know what an append-only log is? Right. Again, that's one of the things that makes it sound cool, because like when you know what it is, it's like, oh, it's so simple. And if you don't know what it is, it's like, oh, I don't know. So like it's basically just a log, and by a log I mean just a list, and you just append to it. That's the append-only part. You just never delete from it, because that makes it really, really easy to distribute, right? So basically the idea is that if you have something like a database, every time you do an operation on the database, like if it's a key value store, every time you delete something or insert something, you just append this to this log, right? So you kind of end up having a log like this. That's like, oh, first I'm going to insert a key. It's called a copy called hello. The value is world. It's a put, by the way. Then afterwards, it says like hi Oakland, right, on the key hi. That's also a put. Then if I delete something, I don't delete the first entry here. I insert a new entry, and I say like that's a delete. So basically, if I read this entire log, and I kind of like, resolve every entry from 1 to 2 to 3, I end up with something like my key value store contains like hi Oakland, right? Because I deleted the other things. So like this is really easy to replicate, because if I have a log like that and you have a log like that, and I want to get your log, like let's say this other guy has like 3 entries in his log. What we do is that we just go back here. Like if this guy has 3 entries in his log and I don't have anything, I just start by telling the other guy, can you give me everything from 0? Because like that's what I have. I have 0. The other guy's like, sure, 0. I have like from 0, my head is 3, so like the diff from 0 to 3 is 1, 2, 3. So he sends me that thing. That's really simple. And like now I have 3 entries in my log, those 3 entries. So if I wanted to replicate again, I would tell the guy, can you give me everything from number 3? And he would send me like the diff of that was just like nothing, because he has 3. That's the head of his thing. So that's really simple. So now I have this other guy's log and I have my own log, right? So we might want to have a situation where we want to get every log that's ever been distributed. This is like really easy to do, because what we do is we just, instead of just sending the head of like my log of the other guy's log, like just sending the head of DB1's log, I just send him the heads of every log I have, basically. So if you have a situation here where like this other guy has 2 logs, he has DB1's log, he has 3 entries from this guy, and he has DB2's log, he has 2 entries from that guy. If I wanted to replicate to him, I would just start by sending him all the heads of my local logs, which is nothing, because I don't have anything right now. And this guy would say like, okay, so nothing, the diff from nothing to my thing is like DB1 to 3 and DB2 1 to 2, right? So he sends me like those 5 entries. So if I wanted to replicate with this guy again, I would just send him the head of my local logs, which is now like DB1, that's the head of that one is 3, and the head of DB2 is 2, right? So I would send him that little information. And he would like calculate the diff locally, and the diff of that locally is nothing, because he already has DB1 3 and DB2 2. So this is a really simple like replication mechanism for distributed replication logs. So if Dominic was here, he would tell you that this is called Scuttlebutt, because he wrote like most of this shit. I'm just going to steal his thunder and take credit for it. So this is really cool, because it's really simple. It has like one, and the cool thing about it is that we don't even need to be connected to everybody in this network to kind of get everybody's log, because we just need to kind of have a path between everybody, and then eventually, that's eventually consistent, we will get everybody's log. So that's really cool. That's kind of like, the same situation with Git, where you don't push to everybody. If I push to Max and Max pushes to someone else, I know that someone else would get my changes eventually, because like I pushed them to Max, right? So he carries my changes along. So that's a really cool property. It has like one big trade-off that might be okay for your use case. I think Substack is going to talk about that. But like, you might have a situation where we cannot make the assumption that someone's log arrives before someone else's log. We just know that eventually you will have everybody's log, right? So if Max inserts something in this key value store, and key like hello, right? So like if Max says hello is now world, and like I say, well, hello is verden, because that's the Danish word for world. So that's the true one. And like we replicate, it's really hard to make an assumption here that's like one of them is going to win, because there's really no ordering between these 2 logs. So how would we solve that? Which is like a big problem we would have in that, because that is basically, you can kind of boil that almost down to a distributed key value store in this kind of sense. So we need to pick someone that wins, and we need to pick someone that wins consistently. And we could just pick like Max because X is higher than T, and like alphabetically that's source higher, but it's kind of like a shitty way of picking one, because like mine is obviously better. So like, how do you fix this? And this basically, you fix this by doing something called a merge, right? So I'm just gonna quickly show this thing that I wrote on the plane right over here. And I named it yesterday because I saw Substack talk yesterday, and I thought like hybrid, that sounds cool. So I'm calling this thing Hyperlog. So it's basically just it's very, very young and new, but like I think this is going to be, it might be the foundation of that going forward. The idea is basically that if I go back to my log slide here, that entries in a log can have references to entries in another log, right? So basically, DB2 here might say, dude, I'm totally merging like DB1, 2, right? Because then I know if I get this entry here out of order, I know that if I somehow afterwards get this entry, it's like that's entry shit because like this guy's merging it. And also I know like if this guy down here if he's referencing DB1 free, I actually don't need to send him this head of the DB1 log because I know if I send him the value of DB22, he gets a reference to the other log, right? So it kind of makes the handshaking really, really simple. So I know this is advanced stuff, and it's like it only makes sense to me because I've spent a month digging into it. So I'm trying not to sound very smart and make it call it simple and shit. But anyways, I'm just gonna try to do a quick demo of it, and then I'm gonna get off the stage. I should probably stop replicating this thing. So actually, a really cool thing about this is that it actually works even though you're offline. So if I just shut off the torrent, but I can still boot it. Maybe. Yeah, I can still boot it because like everything's synced locally. So that's a really cool thing. Anyways, so I can still run like, what's the version of Node? Awesome, right? So anyways, the hyperlog thing, if I demo. So if I make 2 folders here, so like we have 3 peers in this system. I should probably make this bigger. I can go in here and I can call like hyperlog, add a message like hello world. Like that. This would be max that says hello world, right? And I should be able to print this thing out. So like it says, oh, there's one message in the log. It's hello world. It has this key. If I go into like another folder, let's assume that this other folder will be a different machine. I could run at like hyperlog at hello Verden. And if I print this thing out, oh shit, it says like, oh, this is hello Verden now. So what I could do is I could pull the changes from the other log into this log. So that pulled the changes using the algorithm I very, very quickly described that nobody's understanding. And if I print this thing out now, I'll say like there's two values here. But if we tell it like print out the heads, which heads means that everything that's at the top of the log, it says, oh, there's 2 now because these values are kind of conflicting. So what I can do is I can add a new one, and this local demo I have just implicitly merges these 2 values into new value. So I'm just going to say like add hello real Verden. Oh, read real. There we go. So if I print this out now, this thing will have 3 values. And you can see here this links, and the link is kind of like a merge, because a merge is a very high level concept. A link I think is a bit lower level, doesn't matter. Like this links 2 values now, and you cannot read this, but like this, one of these values is this one, and the other value is this one. So I know that if I read this thing, and this has like a merge of these 2 things, I should know these, like one is in the bottom, basically. That's kind of cool. And like we have the same property as we do in Git, where if I go to the other peer again and do like print this guy out, I can pull in the changes from this other peer, and like it's still resolved, right? We don't get a conflict or anything like that, and it will always resolve in a nice way. So yeah, if that's more or less it. So yeah, anyways, so this is like I think it's going to be the foundation for that going forward, and it's gonna be pretty cool. So yeah, if you want to talk about that or just want to talk about Bittorrent or anything, hit me up afterwards. That's it. Thanks, everybody.